Hello everyone. So I'm Antoine Vastel, head of research at DataDome, and today I'm going to talk about CAPTCHA and bot protection. So I will start with bots and how complex bots have become and what bad bots look like in 2022. Then I will continue to talk about bot detection signals. We'll talk about CAPTCHA, how traditional CAPTCHA work, and how new CAPTCHA should work. And then we'll conclude with our own DataDome CAPTCHA and show you the kind of signals, the kind of challenges that you should use in a recent CAPTCHA. So first, what does a bad bot look like in 2022? The first thing to know is that bots and hackers will target every endpoint of your infrastructure. So in general, people will start by securing server and their APIs, because that's where attackers and bots can retrieve structured content, for example, using the JSON format. But that's not enough. Let's say you implement a server-side or API protection. Attackers will still try to find the weakest link in your infrastructure, and they will probably be able to find the content they are looking for on the client side, for example, in the mobile app or in the HTML of the website. So it's really important to secure all the endpoints of your websites and application. Bots will also use the same technologies as human. By that, I mean that it's really easy, it's really straightforward for an attacker to create a bot that has a really similar fingerprint as a human user. So they can do that using open source frameworks like Puppeteer, Puppeteer Extra Stealth, modified Selenium. But if they don't want, to create their own bot by themselves, they can also, leverage services like Browserless, for example, that enables an attacker to easily create, spawn a headless browser in the cloud, and they will take care of everything for the bot creator. So they will spawn the headless browser in the cloud, no need to manage the VMs yourself, for example. Attacks are more and more heavily distributed. So on this slide, what we see is a map that shows the distribution of a credential stuffing attack that occurred a few months ago. And the bots were operating from millions of IP addresses all around the world, which means that each IP address made only 1 or 2 login attempts on average. Because of that, traditional rate limiting techniques, IP-based rate limiting techniques in particular, are not really effective against this kind of attacks, because each IP will make only a few login attempts. And on top of that, bots use more and more clean IPs. So what we see at DataDome is that a third of bad bots use residential proxies. So residential proxies are IP addresses like the one I have and like the one you have at home. So it belongs to well-known internet provider like Comcast, AT&T, if you are located in the US, or Deutsche Telekom, for example, if you're in Germany. And so it's way more difficult for a website to detect bots operating from these IPs, because they are the same IPs as the one used by your users. Also, what we see is that attackers are willing to pay a lot for clean residential proxies. So on the right part of the screen, we see that to get 60 ISP proxies for 2 months, it costs up to $500. But because the return on investment is so high for attackers, they are willing to pay for these really clean proxies, because it maximizes their chance of having a successful attack. Bots can pass CAPTCHA. So CAPTCHA are not enough to secure your website or your mobile application. And how can attackers forge CAPTCHA? They have different ways to do that. They can use modified versions of Puppeteers, for example, Puppeteers Extra Stealth. They can use image or audio recognition techniques, or they can also leverage CAPTCHA farms. CAPTCHA farms will put human in the loop, so that these humans can solve CAPTCHA on the behalf of bots. And it costs around $3 to solve 1,000 reCAPTCHA, and it makes traditional CAPTCHA ineffective against this kind of attackers. And finally, there is a new trend, a new shift, let's say in the bot industry. It's what we call bot as a service. So services in the bot community or around bots are not new. So in the previous slides, I already showed you a few services. For example, I showed you browserless that enables a developer to spawn headless browser in the cloud. We also had traditional proxy providers. So for example, Luminati provided access to a network of residential proxies located all around the world. And on the previous slide, I also showed you CAPTCHA farms, which enable attackers to make an API request to ask a CAPTCHA farm worker to solve a CAPTCHA on the behalf of his bots. But the new shift, I would say, is that all these services merge together to provide a really simple service to use. And this shift, this change, is really well illustrated by Luminati that became Bright Data a few months ago. And so while Luminati was selling themselves as a proxy provider, Bright Data sells themselves as a service that enables companies to access any kind of data even when they're protected. And so Luminati was selling us access to a proxy network, while Bright Data, they will take care of all the difficult part for you. So you don't need to spawn a headless browser, you don't need to rotate IP addresses using proxies, you don't need to spoof your fingerprints. These bot as a service, they will take care of it for yourself. So you don't need to be a bot expert anymore. The difficult part of making bot is handled by this bot as a service. Okay, so now that I showed you, how complex and sophisticated bots were in 2022, I will show you the main kind of signals that we can use to detect bots. So there are three main families of signals. The first one are signatures. So when we talk about signatures, it can be, for example, HTTP headers, it can be TLS fingerprinting, or it can be, any kind of client-side fingerprints, for example, collected in the browser or in a mobile application using an SDK. Then we have all the behavioral signals. So when it comes to behavior, we can study the user behavior on the client side using client-side events, for example, mouse movements, touch events, but it's also the server-side browsing pattern. So whenever a user makes a request, we can study the time series or the browsing pattern of this user on the server side. And finally, the last category is all the reputational signals. So you can compute different kind of reputation. You can compute reputation on the IP address, on the session, on the user ID. You can also detect whether or not an IP address has been used as a proxy and what this IP address is doing on other customers, on other platforms. But let me show you a few examples of these signals. So for example, when it comes to server-side signatures, so I said we had HTTP headers. What can we use when it comes to HTTP headers? For example, we can study the order of headers. We can also study the absence or the presence of certain headers. And we can, in general, look whether or not the headers are consistent with the identity of the device claimed in the user agent. So for example, if you pretend to be on Chrome, but you're not sending any accept language header, it's not normal because all the latest version of Chrome will send this header. We also have other kind of server-side fingerprints like TLS fingerprints. The idea of TLS fingerprinting is to leverage TLS client hello data during the TLS handshake. And we can collect information like the cipher suits, the extension list, the TLS version, and verify whether or not it's consistent with the operating system and the browser claimed in the user agent, or whether or not it's linked also to a HTTP client library. On the client side, we can also collect highly valuable signals. For example, we can collect information about the operating system, the browser, the type of device. We can also collect information about the GPU, the list of plugins, the number of CPUs, and it can help us, verify whether or not the user has a consistent fingerprint, or if the fingerprint has been forged or is linked to an instrumentation framework. And for these instrumentation frameworks or the headless browsers, we have really specific challenges. that enable to detect malicious activity in a single execution. So with these special JavaScript challenges, for example, we can detect the presence of Selenium or modified Selenium frameworks, and same for Puppeteer and Puppeteer Extra Stealth, Headless Chrome, and Playwright. But on the client side, as I said, we'll also collect other behavioral signals. So on the client side, for example, you can collect information about the mouse movements, about the clicks, about the touch events. You can do it from the browser with JavaScript, or in a mobile application using an SDK. And all these signals, whether it is server-side signals, client-side signals, are used in detection to predict whether or not the users on the website is a human or a bot. So now I'm going to talk about CAPTCHA. So everyone knows CAPTCHA, and also everyone tends to hate CAPTCHA in general. So what the main challenge with a traditional CAPTCHA, the security of a CAPTCHA relied on the difficulty of the challenge. So the goal was to show a challenge that was supposed to be really difficult for a bot or a program and straightforward for a human. In general, these challenges, they were based on image recognition or audio recognition, because until a few years, it was really, easy for human, let's say, but really difficult for a program to achieve this task. With all the recent progress in artificial intelligence, image recognition, audio recognition, most of the bots can really easily forge CAPTCHA, because they can easily identify objects in images, or translate an audio file to convert it to numbers or words. In this situation, the only solution was to make the challenge even more difficult for human, in order to maybe make it also more difficult for bots. But the problem with this strategy is that it adds a lot of friction for real human users. And as we have seen in the previous slides, CAPTCHA farms rely on human to solve CAPTCHAs. So it means that even if you increase the difficulty of these challenges, some humans in this CAPTCHA farm will still be able to forge them. So the security of your system is still not enough if you rely only on this kind of CAPTCHA. So it's a real problem from a security point of view, because CAPTCHA farms have human in the loop to solve challenges. So even if you increase the difficulty of the challenge, it won't be enough in this situation. And also because AI constantly makes progress, particularly in image and audio recognition field, it's become really easy for a program to solve this kind of CAPTCHAs. And let's say you're not able to do it yourself, there are a lot of APIs provided by Google, by AWS, by Microsoft, that enables you to easily identify objects or translate audio file automatically. And on top of that, because we are increasing the difficulty of the challenges, it's not even solving the security challenge, but at the same time, it's increasing this increase of difficulty is hurting real human user experience. And on top of that, traditional CAPTCHA providers tend to collect a lot of personal information that may not you may not be compliant with regulations like GDPR, for example. So now I'm going to explain how CAPTCHA should work. In general, when someone uses CAPTCHA, it's to solve an issue. It can be to solve a fraud issue, it can be to solve a bot issue. But what we argue is that your CAPTCHA should not rely solely on the difficulty of the challenge to stop bots. Okay? Because anyway, at some point, your CAPTCHA will become unusable for real human users and will still be passed by bots. So constantly increasing the difficulty of the challenge, we don't think it's a right approach. And on top of that, your bot protection in general, or your system to stop fraud, shouldn't rely solely on CAPTCHA to stop bots. Because anyway, at some points, bots will find their way around your CAPTCHA. They may use image recognition techniques. They may leverage CAPTCHA farms. But anyway, at some point, they may be able to forge CAPTCHA. And so you need something stronger to secure your system. To do this, you need an accurate protection that leverage different kinds of signals. And that's the signals that I showed you before when it comes to bot detection. So you need to collect different kind of signatures. You need advanced browser fingerprinting technique, for example, using JavaScript or using SDK to collect information about the user device, about the operating system, about the browser or the mobile application. You also need to collect behavioral signals like mouse movements, touch events, or the time to solve the CAPTCHA. And on top of that, you should also have a strong reputational approach. For example, to collect information about the session reputation, the user ID reputation, the IP address, whether or not it's a proxy, and combine all of this to secure your CAPTCHA. You should also integrate anti-CAPTCHA farm mechanism in your CAPTCHA, or use a CAPTCHA that has anti-CAPTCHA farm mechanism, because at some point, if you have highly valuable data, attackers will try to bypass it, to provide a way to forge it. And so the idea is to have a CAPTCHA that natively integrates mechanisms against CAPTCHA farm. So for example, you may want to be sure that the CAPTCHA has mechanisms, for example, to verify that the user that got blocked is the one that solved the CAPTCHA. That's not something that you will find in all CAPTCHAs by default. And at the same time, you want to be sure that your CAPTCHA is not shown to everyone. You want to minimize the number of times you show a CAPTCHA, because showing a CAPTCHA is, even if the CAPTCHA is simple to use, it's still not good from a user experience point of view. So you want to minimize the number of times you show a CAPTCHA. So how do we do that? To do that, we created the DataDome CAPTCHA. The way we built it so that it's easy for humans. So as you can see, it's a slider. You just need to move, the fragment to the right position. So it's really straightforward for any human users. No need of any explanation. But at the same time, it's hard for bots. Why? Because in the background of this CAPTCHA, we collect a lot of signals. We collect a lot of fingerprinting signals, a lot of behavioral signals, and we leverage a lot of reputational signals about the session, about the IP address. And we combine all the signals using machine learning, and it enables us to have a easy-to-use CAPTCHA, but that's also really secure. And to show you how it works, so our CAPTCHA has been in production on e-commerce websites, on gaming websites, on classified websites for several months. And on average, it's stopping more than 150,000 CAPTCHA forging attempts every day. It means that every day we have attackers that try to submit to forge CAPTCHA because we block them. And even if the response of the CAPTCHA is valid or not, actually, we still, invalidate the CAPTCHA passing attempt because of the fingerprinting signal, because of the behavioral signal we collect. Because we know that even though the challenge may be correct, the signals are linked to malicious bots. For example, it may be LS Chrome, it may be modified Selenium, it may be Puppeteer extra cells. And because of that, we add an extra layer of security on top of the challenge of the CAPTCHA itself. What's interesting is that when we started to deploy this new CAPTCHA, we wanted to study how attackers would adapt, because we knew that attackers would adapt. We knew that they were going to try to forge CAPTCHA. And so depending on the website and the mobile applications, it took between 6 hours to 2 weeks. So it's huge differences, but it really depends on the website. But because DataDome's mission is really to secure website and mobile apps from fraudulent traffic, we constantly monitor activity on our CAPTCHA, and we collect new signals, we leverage new signals, we update our machine learning models to ensure that even when attackers try to forge CAPTCHA, then we can still block them. So how do we do that? We continue to collect new fingerprinting signals, we continue to add new machine learning behavioral models, for example. We also studied how attackers tried to forge CAPTCHA. So one of the first things we noticed is that attackers were using the audio CAPTCHA to forge it. So DataDome CAPTCHA has two modes. One, visual mode, where you can slide a fragment to the right position, and a second mode to be compliant for accessibility that leverage audio. That's an audio challenge. basically where we pronounce numbers in several languages depending on your website and your user preferences, and the user has to type the numbers that were pronounced. And so attackers were trying to leverage the audio CAPTCHA. They were using probably some audio recognition API to infer the right number pronounced. But because we have some fingerprinting, behavioral detection, we were able to successfully mitigate these forging attempts. We also detected a lot of non-modified puppeteer bots. So these were simple bots that were using AI image recognition techniques and were using fake mouse movements, to slide the fragment to the right position as if they were real human. But once again, because we have JavaScript challenges that enable us to quickly detect that it's not a legit Chrome or any browser, but it's a puppeteer, we were able to invalidate these CAPTCHAs. We also saw a lot of puppeteer extra stealth bots, which is not a surprise because this framework is really popular among bot developers, including bot as a service. And so basically they were using similar approaches as bots that were using puppeteer, but with more realistic browser fingerprints. And finally, we also detected something quite interesting. So we detected a lot of code injected by the 2CAPTCHA auto solver extension. So 2CAPTCHA is a CAPTCHA farm service, and you can leverage this service using different techniques. You can access it through an API, but they also propose a browser extension. And so for the moment, 2CAPTCHA doesn't propose any option to solve the DataDome CAPTCHA. But because bots probably didn't adapt yet, we detected a lot of bots trying to inject code related to the 2CAPTCHA autosolver extension into the page of the CAPTCHA, because our CAPTCHA page can detect these kind of things. And so we detected a lot of bots trying to forge CAPTCHA using this CAPTCHA farm. So it's really popular. Until recently, we didn't have any proof or metrics, but we are able to actually measure the number of bots trying to solve CAPTCHA using this extension. So to summarize, bots are more and more sophisticated. They have realistic fingerprints. They can get realistic fingerprints using open source frameworks, using bot as a service, or using services like browserless, for example, that enables attacker to easily spawn headless browser in the cloud. They tend to distribute their attacks even more. So in the past, attackers were using a few IP addresses to make a lot of requests. Nowadays, they use a lot of IP addresses, most of the time clean residential proxies, to heavily distribute their attacks and make it look like it's coming from a lot of devices, which enables them to bypass traditional IP-based rate limiting techniques. And on top of that, attackers tend to forge CAPTCHA, traditional CAPTCHA, either using audio or image recognition techniques or using CAPTCHA farm services. That's why traditional CAPTCHA are not enough to secure your website or mobile application, and it's important to have a continuous bot detection monitoring. You should continuously monitor the activity of your users on your website to ensure that it's not bot activity. And what's important if you still need to use a CAPTCHA, because let's say you detect malicious activity, you want to challenge it, you send the CAPTCHA. You want a CAPTCHA that does not solely rely on the security of the challenge itself to be secure. You want a CAPTCHA that collects signals in the background, for example, fingerprints, behavioral analysis, session, IP reputation, to ensure that the user passing the CAPTCHA is still a legitimate user, to ensure that it's not a bot that was using AI audio-based recognition techniques to forge your CAPTCHA. And you also want a CAPTCHA that ensures that it's not a CAPTCHA farm that will solve the CAPTCHA on the behalf of a bot. And on top of that, you want a private CAPTCHA, a CAPTCHA that respects your user privacy, because traditional CAPTCHA providers may collect a lot of signals that they may not only use for security purposes. They may collect these signals for marketing, for targeted advertising. So it's really important to have a CAPTCHA that collects only the right set of signals and use it only in a security context. Thanks a lot for your attention.